Welcome to this lecture of numerical analysis. In this lecture, we will study the Picard's method of successive approximations to solutions of an initial value problem. To solve an initial value problem of this form, dy by dx is equal to f of xy with the initial condition y of x naught is equal to y naught. We define the nth Picard's approximation. The nth approximation to the solution is given by, yn plus 1, which is defined as y naught plus integral x naught to x f of x yn dx, where n is greater than or equal to 1. So this is how Picard's method of successive approximations is defined. We are given an initial value problem y dash equal to f of xy with the initial condition y of x0 equal to y0. Then the nth approximation is defined as yn plus 1 equal to y naught plus integral x naught x f of x yn dx. So now let's take up an example to understand this properly. Again, actually using the Picard's method, we will obtain a series solution. So let's move towards the solution. So what we are given? We are given f of xy is equal to 1 plus xy. We are given x naught, which is equal to 0. We are given y naught, which is equal to 1, because pi of 0 is equal to 1. So x naught is 0 and y naught is 1. Now in the nth approximation, we need the value of f of x y n. So hence we can define f of x y n, which is 1 plus x y n, where n is greater than or equal to 1, which is by definition of f of x y. Now we can define the approximation step by step. So let's move towards writing down the first approximation. So first approximation is which we shall denote by y1. Now using n equal to 1 in this formula, we get y1 is equal to y0 plus integral x naught to x f of, actually n equal to 0 here, so we shall write n greater or equal to 0 here, comma y0 dx. Now substituting the value for y naught, so y naught is equal to 1 plus x naught is equal to 0, x is same as x. Now here this becomes f of x comma 1 dx, which is equal to 1 plus integral 0 to x. Now f of x comma 1, x is same as x, and instead of y we write 1 because y naught is equal to 1 here. So this becomes 1 plus x dx. Now we integrate this 1 plus x, so this becomes 1 plus. Now integral of this 1 is x plus integral of x is x squared by 2. And even using the values of the limits of integration from 0 to x, we will obtain the same value, 1 plus x squared by 2. So this is our first approximation. Now let's move towards the second approximation, which we shall denote by y2, which is by definition equal to y naught plus integral x naught to x f of x y1 dx. So this is equal to y naught plus integral x naught to x. Now f of x y1, that is equal to 1 plus x into y1 dx. And we already know the value of y1. So now substitute the value of y naught, that is 1 plus integral x naught is equal to 0, and here we have x. Then 1 plus x y1 is equal to 1 plus x. Now y1, as obtained in the previous case, it was equal to 1 plus x square divided by 2 dx. So this is equal to 1 plus integral 0 to x. Now let's take this product. This becomes 1 plus, now here x into 1 is x, plus x into x is x square then plus x cube divided by 2 dx. Now we can integrate this. This is equal to 1 plus, now integral of x, integral of 1 is x, then plus integral of second term, that's x, its integration x square by 2 plus integration of x square, that's x cube by 3 plus integration of x power 3 by 2 is x power 4 divided by 4 into 2, that is 8. So that is our second approximation. Now as we are asked to find the first three approximations, hence we can find the third approximation. Hence the third approximation is,
which we denote by y3, which is y3 and defined as y0 plus integral x0 to x f of x y2 dx. So which is equal to y0 plus integral x0 to x, now f of x y2, that's equal to 1 plus x y2 dx. Because f of xy is equal to 1 plus xy, so f of xy2 is 1 plus xy2. So now substitute the value of y0, that's 1 plus integral x0 is equal to 0, so 0 to x, 1 plus xy2, 1 plus x, and y2, as we know in the previous case, it is 1 plus x square by 2 plus x cube by 3 plus x power 4 divided by 8 into dx. We need to integrate this whole term. So now we can integrate, this is equal to 1 plus, now integration of 1, that is x, then plus x into 1, its integral is x square by 2 plus x into x is x square, its integration is x cube by 3 plus x into x square is x cube, so its integration is x power 4 divided by 8 plus x into x power 3, that is x power 4, so integration will be x power 5 divided by 5, 5 into 3 is 15 here, then plus x into x power 4, that becomes x power 5, and integral of x power 5 is x power 6 divided by 6 into 8, that is 40. So this is the third approximation to the solution of the given initial value problem.